Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 16 practice problems that should closely mirror what you'll see on the Arithmetic Reasoning subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the PiCAT. If this is your first time finding my YouTube channel, I quickly want to mention this. You can take a practice test that has these questions in it on my website. My website is asvabapp.com, and these questions come from my 6th full-length AFQT practice test. So again, you could go to my website and take this practice test. Otherwise, you're more than welcome to follow along here on YouTube. In that case, I'd recommend that you pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB. So regardless of where you're taking this practice test, make sure not to use either of those resources. Finally, I want to mention that in the description of this video, I'm going to include timestamps that are associated with each question. Next to the timestamp is going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if at any point during this video you feel as if you need more help with one of these topics, just check out the description of this video, and there you'll find those links to those additional videos. So all that being said, let's go ahead and get started with today's video. All right, so let's scroll down a little bit so we can see this first problem better. It says a flagpole cast a shadow 28 feet long. A person standing nearby cast a shadow 8 feet long. If the person's 6 feet tall, how tall is the flagpole? So in this case, we're comparing the height of the man compared to his shadow versus the height of the flagpole and its shadow. So let's make a little diagram to illustrate that. Here's the man, and we're told he's 6 feet tall, and here's his shadow. According to the problem, that's 8 feet long. Here's the flagpole. Now, we're not told what the height of the flagpole is. That's an unknown value. And in math, you can represent unknown values with x. That said, we're told it casts a shadow that is 28 feet long. Well, if you enclose these figures, you'll see that they become right triangles, and now we're comparing similar figures. The height of this man to his shadow has to be the same as the height of this flagpole to its shadow. So that looks like this. Again, the ratio of the height of the man, 6, to his shadow is 8, has to be the same as the height of this flagpole, x, to the length of its shadow, 28. All right, so now we just have to solve this proportion and we'll be done. To solve proportions, you cross multiply. So this will become 8 times x, which is 8x. And then this is 6 times 28. If you can't do that in your head, you can work it off to the side. We have 28 times 6. 8 times 6 is 48, carry a 4. 2 times 6 is 12, 13, 14, 15, 16. So 6 times 28 is 168. So we have 8x equals 168. Now we're going to divide both sides by 8. This will cross out here, leaving you with x equals 168 divided by 8. Now, some of you would say this is the same as 168 divided by 8. And you can certainly work it out that way. But that said, time is precious on the ASVAB. So you should notice that we have 16 and 8 here. What is 16 divided by 8? Well, that's 2. And what's 8 divided by 8? That's 1. So x in this case is 21. We know that x is the height of the flagpole, so we can say with confidence that the height of the flagpole is 21 feet. All right, so that's the test of your ability to identify similar figures and set up a proportion to solve them accordingly. All right, so that's that one. All right, number 2 here says a silver bracelet that regularly sells for $44 is currently on sale for 25% off. What is the sale price of the bracelet? All right, so on my channel, I have a video as to how to calculate tax, tips, discounts, double discounts, and find original price. So if what I'm about to do is something with which you struggle, go ahead and watch that video. I think in that video I work out about 10 examples. So that said, the setup to this one is like this. You want to represent what's going on here algebraically. And we want to know what the sale price is of the bracelet. So we're going to say sale price is equal to, well, what's the sale price equal to? It's the original price of the bracelet minus the discount from the bracelet. Well, that's going to be discount amount times the original price. All right, what is the discount amount? We're told right here it's 25%. And on the ASVAB, you're always going to express percents in decimal form. So the decimal form of 25% is 0.25. What's the original price? It's right here. It's $44. So all we have to do is plug those two things in, and we'll be able to find our sales price. So this is sales price equals original price, that's $44, minus the discount amount, that's 0.25 in decimal form, times the original price, that's $44. All right, let's work this out. First things first, let's take care of this 0.25 times 44. I'm going to work that off to the side. We have 44 times 0.25. As you can see, we're multiplying a whole number by a decimal. The trick to doing this is to clear the decimal. So to clear the decimal in 0.25, I'm going to shift it 2 times to the right, and this becomes 44 times 25, albeit with 2 decimals to shift back into the left at the end. Again, I move the 2 decimals to the right here. I have to shift them back into the left here. So let's work this out. We have 4 times 5, which is 20. So we're going to drop down a 0 and carry a 2. 4 times 5, which is 20, plus 2 is 22. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 4 times 2 is 8. 4 times 2 is 8. Let's add these together. 0 plus 0 is 0. 8 plus 2 is 10, so carry a 1. 8 plus 2 is 10, plus 1 is 11. Bring in our 2 decimals, 1, 2. So this becomes 44 minus 0.25 times 44, which we can see is 11. All right, and if you can't do this in your head, let's do it off to the side. We have 44 minus 11. 4 minus 1 is 3. 4 minus 1 is 3. So we can see that the sales price of this bracelet is $33, which is answer choice A. All right, so that's that one. All right, so number 3 here says there are 40 teachers who work in a middle school. On Friday, 25 teachers were at the school and the rest were on a field trip. What percent of the teachers were at school that day? All right, so in this case, we're told that 25 of the 40 teachers were at the school that day. And now we have to convert this fraction into a decimal, which then we'll be able to convert very quickly into a percent. The way you convert fractions into decimals is via long division. So we would read this as 25 divided by 40. That said, prior to doing long division with big numbers, you want to try to reduce them as much as possible. And in this case, you should see that 25 and 40 are both divisible by 5. 25 divided by 5 is 5. 40 divided by 5 is 8. All right, so now we're going to convert this fraction into a decimal, and we're going to read this as 5 divided by 8. The question becomes, how many times does 8 go into 5 without going over? It doesn't, so I have to add a decimal here and a couple of 0 placeholders. Once I add that decimal, I'm going to bring it up right here. And again, we said 8 does not go into 5, so we'll put a 0 here to represent that. And now the question is, how many times does 8 go into 50? Again, we disregard this decimal now because we counted for it up here. How many times does 8 go into 50 without going over? Well, you should know that's going to be 6 times, given that 8 times 6 is 48. 50 minus 48 is 2. Drop down this 0 here. How many times does 8 go into 20 without going over? That's 2 times. 8 times 2 is 16. 20 minus 16 is 4. Again, we have as many 0 placeholders as we want here. All right, so we can drop down this 0 now. And the question becomes, how many times does 8 go into 40? That's going to be 5 times, and 8 times 5 is 40. 40 minus 40 is 0. So 5/8, or 5 divided by 8 is 0.625. And to convert a decimal to percent, we just shift the decimal place 2 times. So this is 1, 2. This becomes 62.5%, which we can see is answer choice D in this case. All right, so that's that one. All right, so number 4 here says Andy earns a monthly salary of $500, as well as a commission of $10 for every sale he makes. How many sales must he make to earn $3,000 in 1 month? All right, so we're going to have to take this word problem and represent it algebraically, which some people struggle with. But let's take this one step at a time. He earns a monthly salary of $500, so that's 500. And then we're told he makes a commission of $10 for every sale he makes. So that's going to be plus $10 times the number of sales he makes. Well, that's an unknown value. And in math, we represent unknown values with x, y, and z. So let's call the number of sales he makes x. So this is 500 plus 10x. And we want to know what this has to be for him to earn $3,000 in 1 month. So in this case, we're just solving for x, where x refers to the number of sales he makes. First things first, let's subtract 500 from both sides. This crosses out here, leaving you with just 10x over there. You should be able to do this in your head. 3,000 minus 500 is 2,500. I'm not going to work that off to the side because, again, that one's very easy. All right, so again, we're solving for x, so I'm going to divide both sides by 10 here. This will cross out here, leaving you with x equals 2,500 divided by 10. Well, we can make this a lot easier by crossing out one of these sets of corresponding zeros. So this becomes 250 divided by 1. Well, what do we know about division involving 1? Anything divided by 1 is just itself. So 250 divided by 1 is 250. All right, so in other words, Andy has to make 250 sales to have a monthly salary of $3,000. All right, so that's that one. All right, so number 5 here says an apple pie was cut into 10 equal pieces. A person who eats 1/2 of one piece eats what fraction of the total pie? So one piece of this pie that's cut into 10 equal pieces is 1 over 10. Again, if I were to take 1 over 10 and add it together 10 times, that would be 10 over 10, which would be 1 pie. That said, according to this problem, the person eats 1/2 of one piece. So we have to figure out what 1 over 10 times 1/2 is. And when you multiply fractions, you multiply straight across. 1 times 1 is 1. 10 times 2 is 20. So if a person eats 1/2 of one piece of pie that's cut into 10 equal pieces, they eat 1/20th of the total pie. All right, so that's that one. All right, so number 6 here says, in an auditorium during an assembly, 1/5 of the students are 5th graders, 1/2 are 4th graders, and the remaining students are 3rd graders. If there are 100 students in the auditorium, how many 3rd graders are there? All right, so first we have to figure out what fraction of the students are 3rd graders. And we can do that by saying this. This 1 represents the students in the auditorium, and we're going to subtract out the 1/5 of the students who are in 5th grade, as well as the 1/2 of the students who are in 4th grade. And by doing that, we'll figure out what fraction of the students are in 3rd grade. Well, in this case, we're subtracting fractions as well as a whole number. First thing I'm going to do is rewrite this whole number as a fraction by placing it over 1. And now we're subtracting nothing but fractions. And in order to subtract fractions, you have to have fractions all with the same denominators. In this case, we have a denominator of 1, 5, and 2. Well, it should be pretty obvious to say that 1, 5, and 2 all go into 10. We're going to rewrite all these fractions with a denominator of 10. All right. To make this 1 a 10, I multiply it by 10. And I also have to do that to its numerator. Again, 1 times 10 is 10. 1 times 10 is 10. So we can see that 1 is the same as 10 over 10. To write 5 as 10, I would have to multiply it by 2. Also have to do that to its numerator. 5 times 2 is 10. 1 times 2 is 2. To write 2 as 10, I would have to multiply it by 5. And I'll also have to do that to its numerator. 2 times 5 is 10. 1 times 5 is 5. Now we can go ahead and subtract these fractions. This will become 10 minus 2 minus 5 all over 10. And let's work that out now. This is the same thing as 10 minus 7 over 10. 10 minus 7 is 3, so this is 3 over 10. So 3 out of 10 students are in 3rd grade. All right, so again, 3 out of 10 students are in 3rd grade. What is that out of 100 students? So we're going to have to multiply that by 100. And again, we're multiplying a fraction by a whole number. So I'm going to write 100 as a fraction by placing it over 1. This is actually pretty easy to do. We can say 10 goes into 10 one time, and 10 goes into 100 10 times. So this becomes 3 over 1 times 10 over 1. 3 over 1 is 3. 10 divided by 1 is 10. So this is 3 times 10 are 30. All right, so 30 of the students are in 3rd grade. All right, so that's that one. I do have videos on dealing with word problems involving fractions. So if you struggled with what I did there, you may want to check that video out. All right, so number 7 says the following colors of M&Ms are placed in a bowl: 4 yellow, 6 orange, 3 green, 5 blue, and 2 brown. If you close your eyes and randomly select one from the bowl, what is the probability that you select a brown one? So on my reference sheet, as well as my YouTube channel, I have some notes and a video in regard to calculating basic probability. And on my reference sheet and in that video, I say the probability of event A occurring is equal to the number of ways that desired outcome can occur divided by the total number of ways outcomes can occur. So in this case, we want to find the probability of selecting a brown M&M. How many brown M&Ms are there? There are 2. So the probability of that desired outcome occurring is 2. Well, how many total possible outcomes are there? Well, there's 4 plus 6 plus 3 plus 5 plus 2. This says your odds of picking a brown M&M are 2 divided by how many M&Ms there are in the bowl. So this becomes 2 over, and let's do this math right here. We have 4 plus 6, which is 10, plus 3 is 13, 13 plus 5 is 18, plus 2 is 20. So this is 2 over 20. And 2 divided by 20 is the same as 1/10. Again, 2 is divisible by 2, and 20 is divisible by 2, so that reduces to 1/10. All right, so your odds of picking a brown M&M from this bowl are 1 out of 10. All right, so that's that one. Again, check out my video on basic probability if you didn't follow along with what I did there. All right, so number 8 here says, how many feet of a wire fence is necessary to enclose a garden that is a square and has an area of 225 square feet? All right, so we know we're dealing with a square. So let's go ahead and draw one of those. And what do we know about squares? In squares, all the sides are equal. All right, so if this is S, that means this is S, and this is S. According to the problem, we're told this square has an area of 225 square feet. Well, how do you find the area of a square. You would do area equals side times side, which is the same thing as s squared. All right. Well, we know what the area of this square is. A is 225. So I'm going to replace this A with 225. So this is 225 equals s squared. Again, we just want to know the length of one of these sides of this square. So we'll take the square root of s squared. This will cross out here, leaving you with just s. What is the square root of 225? Well, on my reference sheet, I have a list of all the perfect squares you should know. Square root of 225 is 15. So this is s equals 15, which means that the length of the sides of this square are all 15. All right, so this is 15, 15, 15, and 15. Well, now the question wants to know how many feet of wire is necessary to enclose this garden. In other words, we want to know what the perimeter of this square is. Well, how do you find the perimeter of a square? You add up all the sides, so that's side plus side plus side plus side. We know what all those are. All the sides are 15, so this becomes perimeter equals 15 plus 15 plus 15 plus 15. And let's do this mentally. 15 plus 15 is 30. 30 plus 15 is 45. 45 plus 15 is 60. So the perimeter of this square is 60, which means we need 60 feet of wire to enclose this square. All right, so that's that one. All right, so number 9 here says the price of gas in California is $5.25 per gallon. This is 175% of the cost of gas in Florida. How much does gas cost per gallon in Florida? All right, so we're going to have to translate this word problem into an expression that will enable us to figure out the cost of gas per gallon in Florida. So first things first, we're told gas is $5.25 per gallon in California. And according to the problem, this is, well, in math, is equal. So 525 is or equal 175%. Again, we always express percents in decimal form. And the decimal form of 175% is 1.75. So that becomes 525 is or equal 1.75. Of in math is multiply. So 1.75 of or times. So we'll go ahead and add that there. The cost of gas in Florida. Well, the cost of gas in Florida is unknown, and we can represent unknown values with the variable x. So this becomes 1.75 times x. Let's go ahead and clean this up. This becomes 5.25 equals 1.75x. And now we're just solving for x. So we're going to divide both sides by 1.75. This crosses out here, leaving you with x over there. And now we have to figure out what 5.25 divided by 1.75 is. You should be able to do that mentally. 1.75 times 3 would be 525. So this is going to be 3. That said, if you couldn't do that mentally, you could always work it off to the side again. All fractions can be regarded as long division. So you would read this as 525 divided by 1.75. And now, as you can see, we're dividing two decimals. The key to dividing decimals is this. As long as the decimal's only inside the division bracket, you're good to go. If, however, you have a decimal outside the division bracket, you have to shift that decimal outside the division bracket such that it becomes a whole number. And in this case, we have a decimal outside the division bracket, so I'm going to have to shift its decimal in 1.75 2 times to the right to make that 175. And I'm also going to have to shift this decimal in 525 a corresponding number of times. So this becomes 525 divided by 175 with no decimals. And now we start by asking ourselves, how many times does 175 go into 5? It doesn't. How many times does 175 go into 52? It doesn't. How many times does 175 go into 525? Well, let's go ahead and see what 3 gets us. 175 times 3. 5 times 3 is 15, carry a 1. 7 times 3 is 21, plus 1 is 22, carry a 2. 3 times 1 is 3, plus 2 is 5. So 175 times 3 is 525. 525 minus 525 is 0 with so there's no remainder. So we can see x in this case is in fact 3, which means the cost of gas per gallon in Florida is $3 per gallon RA. All right, so number 10 says if the ratio of the side length of square A to the side length of square B is 4 to 9, what is the ratio of their perimeters? So in this problem, we're comparing two squares. We'll call this one square A, and we'll call this bigger one square B. And we're told that the ratio of the side length of square A to the side length of square B is 4 to 9. That said, we're not told exactly what the lengths of these sides are. But that said, as long as these side lengths have a ratio of 4 to 9, we can assign whatever values there we want. So I can say this side length is 4, and this one is 9. And as we can see, that has a ratio of 4 to 9. Well, what do we know about squares? If I let this side be 4, that means this side's 4, this side's 4, and this side's 4. And if I let that side be 9, that means that side's 9, that side's 9, and that side's 9. All right, so now we got to compare the perimeters of these two squares. So let's go ahead and do that. To find the perimeter of any polygon, you simply add up all of its sides. So to find the perimeter of this square A, we're just going to do 4 plus 4 plus 4 plus 4. 4 plus 4 plus 4 plus 4 is 16. And to find the perimeter of this square, we're just going to add up all of its sides. So that's going to be 9 plus 9 plus 9 times plus 9. This is the same as 4 times 9, which is 36. Well, what is the ratio of these perimeters? It's 16 to 36. Well, that's not one of our answer choices, so we must be able to reduce this. Well, we can. We know that 16 and 36 are both factors of 4. So I can divide 16 by 4 and 36 by 4. 16 divided by 4 is 4. 36 divided by 4 is 9. All right, so the ratio of their perimeters is also 4 to 9. All right, so I'm going to let you in on a little secret. The ratio between the side lengths of two squares is the same ratio as their perimeters. Okay, so if you ever see a problem where it says the ratio of the side length of two squares is 4 to 9, what is the ratio of their perimeters? It's going to be the same ratio. All right, so kind of a trick problem there. All right, so number 11 here says, at Jimbo Fisher's car dealership, a particular model comes in 4 trim levels, 5 different colors, and 3 different interiors. How many different versions of this car model can be created from these options? All right, so for this one, we have to understand how to apply the fundamental counting principle. And the fundamental counting principle says to find the total number of different combinations of something, you simply multiply each different level of those combinations. So in this case, we have 4 different trim levels. So we'll take 4, 5 different colors. So we'll multiply that by 5, and 3 different interiors. So the total possible combinations of these 3 options are 4 times 5, which is 20. 20 times 3 is 60. All right, so the answer to this one is simply 60. I do have a video on the fundamental counting principle, and you really need to check it out because it's as simple as looking at these problems, identifying that you can use the fundamental counting principle, and then doing very basic arithmetic to get your answer. All right, so that's that one. So number 12 here says Amy's scores on her first 4 history tests were 84, 85, 88, and 95. In order to get a B in the class, she needs to have an average of at least 80 or better. What score must she make on her 5th test to get a B in the class? All right, so for this problem, we're dealing with averages. And you may recall that to find an average, we simply sum up our data points and we divide that by the total number of data points that we have. So in this case, let's see what's given to us. We know she wants to have an average of at least 80. So average is going to be 80 in this case. And then we have her test scores right here. So let's plug things in. We know she needs an average of 80. So this is going to be 80 equals the sum of her test scores. So that's going to be 84 plus 85 plus 88 plus 95. And then we have to include her unknown score on her fifth test. So we're going to call that X. And then we're going to divide that by how many data points there are. There's 1, 2, 3, 4, 5. All right, so all we have to do at this point is solve for X, and we'll know what score she has to get on her fifth exam. So first things first, I'm going to multiply both sides by 5 here. This will cross out here and here, and this leaves you with 84 plus 85 plus 88 plus 95 plus X equals 5 times 80. If you can't do that in your head, you can always work it off to the side. 80 times 5. 0 times 5 is 0. 8 times 5 is 40. So 80 times 5 is 400. All right, so now we're just solving for X. And what we want to do is combine all these numbers right here now. And we're going to do that vertically since that's pretty tedious. We have 95 plus 88 plus 85 plus 84. All right, let's add these up. 5 plus 5 is 10. 8 plus 4, 8, 9, 10, 11, 12. So this is 10 plus 12, which is 22. So we're going to drop down a 2 and carry a 2. And then we have 8 plus 8 plus 8, which is 24. 9 plus 2 is 11. 11 plus 24 is 35. So this is 400 equals 352 plus X. Again, we're solving for X, so we're going to subtract 352 from both sides. All right, so this crosses out here, leaving you with just X on this side. Let's go ahead and work this out. We have 0 minus 2, which we can't do, so we're going to have to borrow. In fact, we're going to have to borrow from this 4 over here. This becomes 3. This becomes 10. This becomes 9. This becomes 10. 10 minus 2 is 8. And 9 minus 5 is 4. 3 minus 3 is nothing. So X in this case is 48. In other words, she needs to score a 48 on her fifth test to maintain a B average in this class. And as we can see, that is answer choice A. All right, so that's that one. All right, so number 13 here says a gas truck can fill a gas tank at a rate of 250 cubic inches per minute if the rectangular gas tank is 20 inches long, 15 inches wide, and 10 inches tall. How long will it take the gas truck to fill this tank? All right, so there are some clues in this problem that should help you get started. First, we're told this gas truck can fill a gas tank at a rate of 250 cubic inches per minute. So we're dealing with cubes. Anytime you're dealing with something raised to the third power, which is a cube, that should be a clue that you're going to be dealing with volume. So in other words, we're going to have to find the volume of this rectangular gas tank. And the volume of a rectangular prism is length times width times height. And we know all those things. We're told what they are. It's 20 times 15 times 10. Let's go ahead and work this out. There's a lot of ways to do this. You can regard this as 15 times 10, which is 150. 150 times 20. I'm going to have to work that off to the side. 150 times 20. 0 times 0 is 0. 0 times 5 is 0. 1 times 0 is 0. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 2 times 0 is 0. 5 times 2 is 10. Carry a 1. 2 times 1 is 2 plus 1 is 3. So this is 3,000. The volume of this rectangular gas tank is 3,000 cubic inches. All right, so now we got to figure out what 3,000 divided by 250 is. Again, we have a volume of a gas tank that's 3,000 cubic inches, and this gas truck can fill up a tank at a rate of 250 cubic inches per minute. All right, so again, just doing this division here will get us our answer. We're going to cross out these corresponding zeros here. So this becomes 300 divided by 25. And you should be able to do this in your head. 25 goes into 100 4 times. Therefore, we multiply that by 3 to give us 12. 300 divided by 25 is 12. So the answer to this one is C, 12 minutes. All right, so that's all there is to that one. All right, so number 14 here says, together, a husband and wife earn $75,000 per year. If one of them earns $15,000 more than the other, what is the amount of the smaller income? All right, so this problem's tricky because it doesn't tell us how much either of them earn. So let's say one person earns X dollars per year. According to the problem, the other earns 15,000 more than that. So that would be X plus 15,000. And together we know they earn $75,000 per year. So in case it's not obvious, that is one person's income, and that is the other person's income. And as you can see, we just took this word problem and translated it into an equation that we can now solve. And more specifically, we're going to be solving for x. So let's combine like terms. We have x and x, which is 2x plus 15,000 equals 75,000. Again, we're solving for x at this point, so let's subtract 15,000 from both sides. This crosses out here, leaving you with just 2x over there. And let's work this out now. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0 is 0. 5 minus 5 is 0. And 7 minus 1 is 6. All right, so we can see we have 2x equals 60,000. Now let's divide both sides by 2. This crosses out here, leaving you with x equals, and this is actually pretty easy to do. 6 divided by 2 is 3, and then just bring down those zeros. So we can see that x is 30,000, and x is the smaller of the two incomes, so we should say that the person who earns the smaller income earns $30,000 per year. All right, so that's that one. Number 15 says, during physical education class, a student ran 2,640 feet. After taking a break, the student ran an additional 7,920 feet. In total, how many miles did the student run? All right, so let's find the total number of feet they ran. We were told, according to the problem, they ran 7,920 feet and then 2,640 feet. So let's add those together. 0 plus 0 is 0. 2 plus 4 is 6. 9 plus 6 is 15. Carry a 1. And then 7 plus 3 is 10. So in total, they ran 10,560 feet. Now we have to convert this to be in terms of miles. Well, in order to do that, we have to know how many feet there are in a mile. And in 1 mile, there is 5,280 feet. All right. So now to convert this 10,560 to be in terms of miles, we would do 10,560 divided by 5,280. All right. And we can, of course, cross out these corresponding zeros here. So this becomes 10,056 divided by 528. Again, if you can't see the answer to this, and I can, you may have to do this long division, in which case you would say 10,056 divided by 528. And you would start by asking yourself, how many times does 528 go into 1? It doesn't. How many times does 528 go into 10? It doesn't. How many times does 528 go into 105? It doesn't. How many times does 528 go into 1056? Well, we got to estimate this. 500 times 2 would be 1,000. 500 times 3 would be 1,500. So it's going to be about 2 times. Now let's do 528 times 2 off to the side. 8 times 2 is 16, carry a 1. 2 times 2 is 4, plus 1 is 5, and 5 plus 2 is 10. So as it happens, 2 times 528 is 1056. 1056 minus 1056 is 0. So we can see that 1056 divided by 528 is 2, which means that 10,560 feet is the same as 2 miles, which is answer choice C in this case. All right, so that's that one. All right, so question 16 here says, train A heads north at an average speed of 100 miles per hour, and it leaves the station at the precise moment as another train, train B, departs a different station. Train B is heading south at an average speed of 150 miles per hour. If these trains are inadvertently placed on the same track and start exactly 1,300 miles apart, how long will it be before they collide? All right, so for this one, it might be helpful to make a sketch to visualize what's going on here. Again, we have this stretch of track, and these circles represent the different stations. And we're told train A, I'm going to call that train A, is starting in the south and it's heading north. And it's heading north at a speed of 100 miles per hour. And likewise, we're told train B starts in the north and it heads south at a rate of 150 miles per hour. And we're told that the length of this track is 1,300 miles. And we want to know how long it's going to be before they collide somewhere here in the middle. All right. So in light of that, you should realize that you have all the elements of the distance formula. Again, the distance formula says distance, d equals rate times time, where r stands for rate and t stands for time. All right. Again, we know the distance of the track. That's 1,300 miles. That said, we have two different rates here. So what we have to do is actually combine them. So it's going to be rate 1 plus rate 2 times time. All right. And again, we can let rate 1 refer to train A. So that's going to be 100. And rate 2 refer to train B. That's going to be 150. So this is 1,300 equals rate 1, 100, plus rate 2, 150 times time. Again, we want to know how long it will be before they collide. So we're solving for t. So let's just go ahead and work this out. 100 plus 150 is 250. So this is 250t. Now let's divide both sides by 250 to get t by itself. This crosses out here, leaving you with just t. Now we can cross out these corresponding zeros here. So this becomes 130 over 25. And let's go ahead and work that out. Again, we can treat this as long division here by reading it as 130 divided by 25. And the question becomes, how many times does 25 go into 1? It doesn't. How many times does 25 go into 13? It doesn't. How many times does 25 go into 130 without going over? Well, 25 times 5 would be 125. 130 minus 125 is 5. All right. How many times does 25 go into 5? It doesn't. So I have to add a decimal here and a 0 here. Once I add that decimal, I have to bring it up here. And now I can drop down this 0. And the question becomes, how many times does 25 go into 50? Well, 25 times 2 is 50. 50 minus 50 is 0. So we can see that time in this case is 5.2. In other words, it will take these trains 5.2 hours before they collide. All right, so that's that one. I do have a video on distance, rate, and time, and I do work out several examples that are similar to this one. So if you need more help with that, check out that video. But on that note, that's it for today's video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
こんにちは。